Okay, everyone. So we'll continue with the lesson today. So today we will still in chapter 1. So we're going to do units 1.6, 1.7 from that chapter. And we're going to keep talking a little bit more about real numbers. So we talked about real numbers in detail last time. We saw what they are and what are the subsets or subgroups that belong to the set of real numbers. Basically, when we say real numbers, we mean positives, negatives, decimals, fractions, natural, whole, integers, rational, and irrational numbers. So we discussed this in detail in our previous lecture. Then we learned about the signs of addition, subtraction, multiplication, division of real numbers. So today we're going to see some more properties and rules that apply to these numbers. And after that, we're going to introduce algebraic expressions, and also, I believe we mentioned that before briefly. So we're going to learn how to simplify algebraic expressions today using the rules we're going to learn. Using those rules, we're going to learn so we introduced algebraic expressions before, we introduced equations and variables. So today we're going to work a little bit more with those algebraic expressions, see how to combine them, simplify them, and so on, using these properties that we're going to learn today about real numbers. So the first thing we're going to talk about is, okay, let's go right into the properties. Let's dive right into it. So the first property we're going to learn is called the commutative property. Commutative property or rule, same thing. So it's a very simple concept here for this property. Simply means that when you add two numbers, you say 2 plus 3, please mute your mic if you have background noise. So when you say 2 plus 3, it's technically the same as 3 plus 2, both equal to 5. So nothing changed other than the order of the numbers. We switched the positions of the numbers, but the result remained the same. Basically, think of it as shifting or commuting or switching the places of the numbers, the result remains the same. This also applies to multiplication. If you have 6 times 4, you could also write it as 4 times 6. Would basically be the same thing. Okay, so that's what we call the commutative property. It's one of addition, and this one of multiplication. Okay, all it means is basically we flip or we switch the places of the numbers and we get the same result. This property does not apply to division. For obvious reasons. When you say, for example, 2 over 1 or 2 divided by 1 is not the same as 1 divided by 2. 2 over 1 is basically just 2, or 2 divided by 1. It's not equal to, sorry, I mean division here. Okay, so 2 divided by 1 is not the same or is not equal to 1 divided by 2. This is 1/2, 1 over 2 is 0.5. As you can see, they're not the same. So this property does not apply to division. Also, it does not apply to subtraction. When you say 5 minus 2, it's not the same as 2 minus 5. This is 3. And as we learned in last time from the sign, this is -3. So these obviously are not equal. So this commutative property only applies to addition and multiplication. Okay, so remember the name. We have a few more properties. They're very simple to use, very simple to understand. You just need to figure out or distinguish between them. Sometimes it may look similar somehow, but they're not exactly the same. So try to, again, understand the difference between each rule. So that's the commutative property. The only thing that changes is the position of the numbers, okay? That's commutative. Another one is, before I give you the name, let's see if you can figure it out. Let's say we want to try to add 3 numbers. We can do this in 2 different ways, at least 2 different ways. You could possibly add these 2 first, and then add the sum to the 1, or you could start from here with these 2 and add the sum to the first one. According to the order of operations, what do you do first here? Where do we start from if you want to simplify this arithmetic expression?
2 plus 3.
That's right. We do evaluate the parentheses first, PEMDAS, so that's 5 plus 1, that's 6. And from here, we evaluate the parentheses again first, that's 4. That leaves you with also 6. As you can see, we got the same result, even though we did them in a slightly different order. Okay, so please mute your mic if you have background noise. So basically what we did here, we associated these 2 first and added to this one, but here we associated the last 2 added to the first one. What do you think the name of this property is, based on what I just said? This is the commutative. What do you guys think the name of this property is? Since we associate numbers, different numbers in each one, so the name of the property will be the
Commutative property?
The commutative was this one. This is another one. Second one, we associate numbers, different numbers in each example. So the name will be, based on that, let's say, associative.
Associative, yes. Okay. Associative property.
That's right. So this is what we call the associative property. Because when you put things together, you associate them or you gather them. Like here, we use parentheses. So here, the only thing that changes is not the position of the numbers. So the order is the same, 2, 3, 1, 2, 3, 1. But the position of the parentheses change from one to the other. Don't confuse that with this one. Here, the numbers actually move, switch positions. But here, only the parentheses are moved around. So this is what we call the associative property. Okay, so this one is of addition. It also applies to multiplication. Very similarly, we can apply that to this. So we're going to say, so this is of addition, of multiplication. Same way, so we want to do 3 times 4 times 2. We can do this in 2 different ways. So again, we can associate possibly these 2 and evaluate this, or we could evaluate, associate these 2 and we will get the same result. So again, we use the order of operations. So we're going to start from the parentheses. That's 12. You times it by 2, you get 24. Here, if you want to evaluate this, you start from parentheses again. That's 8. If you times it by 3, you also get 24. Okay, so that's basically what we call the associative, okay, property of multiplication. This again, for the same reason as here and here, this will not apply to, or it probably may apply to, depending on the signs. Yeah, you may actually apply to addition and subtractions together. But for now, just remember these main ones. But it will not apply to division and multiplication because this is about the order of operations. And when you put the parentheses, that changes the priority of the order of operations. We talked about the left to right property, the exceptions to PEMDAS. So if you introduce the parentheses, you force a certain part or a certain operation to be done first. But when you have only additions and multiplications, you can associate any 2 numbers or 3 and you still get the same result. Okay, so that's the associative property. The only thing that changes again is the position of the parentheses, not the numbers. So we have one of addition and subtraction. Number 2. Then we have another one. Let's call this one that you're all familiar with. Another property that pertains to these real numbers. It's a famous one. Before I give you the name, I'll let you figure it out. When you have, for example, 2 multiply 3x plus 1. Okay, 2 times, in parentheses, 3x plus 1. What do you think this is equal to? What do you think that is equal to if you want to expand this? So this means 2 times parentheses this. So to simplify or expand this, we simply multiply. So we say 2 times 3x, which is 6x. What else? Everybody? What do you do after that? So we multiply in here.
Plus 2. Plus 2.
That's right. 2 times positive 1, that's 2.
2.
This is what we call, basically we just multiplied. What do you think the name of this property is? It has a specific name other than a multiplication. When you go like this. Another word is we multiply or we distribute. So the property is based on distribute. It will be the
Distributive property.
exactly distributive property, because we basically distributed the 2 over the parentheses. Okay, so the distributive property could also be something like this. Okay, so whenever you see a number in front of parentheses, that means there is a multiplication here, invisible one. This means you gotta multiply that number by everything that's inside the parentheses. It could be only 2 terms like these, or it could be more. So, but you have to multiply that -3 by everything inside. Always start by multiplying the sign, get the signs right. So we have, again, this is a multiplication. If you have a negative times a positive here, so you're gonna write your negative. So 3 times 4, that's 12. 12 what?
X.
That's right, x. Then again, take that same number, -3, multiplied by the second number or term here, which is -2. So -3 times -2 will be?
Positive 6.
That's right, positive 6. Okay, so we just distributed this into this. Again, the distributive property or the multiplication property. Let's do another example here. Sometimes you may see something like this. What does this mean? When you see a negative, parentheses, something inside, what does that mean? Or how do you distribute this? How do you distribute this expression? Everyone in the room, Jessica, Lordine, Rasha, Raul, Jennifer, you guys here?
Yes, sir. Yes.
Yes, I'm here.
Okay, so help me out here.
Here.
What should we do here to distribute this? Basically, we have a negative here. What does that mean? That negative here basically is what? Think of it as an invisible -1 in front of the parentheses. Okay. -1.
Yes.
All right, so you take that negative. You take that negative and you distribute it just like we did with -3 here. So -1 times -5 will be?
So when it's a parenthesis,
positive 5.
there's no number, but it's a negative. It's always -1?
Yes, if you see negative in front of parentheses, think of it as a negative. Okay, so -1 times -5 will be
Positive 5.
positive 5x. What else? -1 times positive 7, which will be negative.
Negative 7.
Okay, so when you distribute, you're using the rules of multiplication. So remember the rules of multiplication from the previous lecture. So negative times negative times positive is a negative. That's basically what the distributive property is. Let's see if we have another one. I believe we have another one called the identity. Identity property of real numbers. Real numbers, something like this. So just like with the other ones, we have two here. We have one of addition. It's pretty simple. Basically what it says is, as we saw the other day with the number line, when you have a number on the number line, there's always an opposite of that number on the other side of the zero. For example, what is the opposite of positive 3? What's the opposite of positive 3 on the number line?
Negative 3.
That's right, it is negative 3. So the identity property, actually, this is not the identity property, this is the inverse. Inverse. So the inverse property of real numbers. Inverse, not the identity. We'll do the identity after this. So it's simple. We have one of addition. What do you do? Basically, you take a number and its opposite. What happens again if you put a number and its opposite together? For example, positive 3 minus 3. That will be? What's negative 3 plus 3? Those cancel out. That will be?
0.
0. That's right. So that's basically what we mean by the inverse property of addition. Inverse property of addition. All it means is you take any number and you combine it with its opposite, they cancel each other out. That's why we say these two cancel out, you get 0 because they're opposite. It's the same number. They're both the same distance from the 0 on the number line. So it's the same distance, they cancel out. Another example. So you may have, for example, -5. What is the opposite of -5?
Positive 5.
That's right, positive 5. And what happens again if you multiply, if you combine -5 and its opposite, positive 5, the result will be?
0.
0. That's right. So whenever you combine a number and its opposite, they cancel out, you get 0. That's what we call the inverse property. Inverse property of addition. There's one for addition, there's another one for multiplication. We're gonna talk about it in a moment. So generally speaking, for any real number x could be positive, could be a decimal, a fraction, positive, negative number, could be anything. What is the opposite of -x?
Positive x.
That's right. So for any number x, could be any of these, the opposite is positive x. And again, the inverse property of addition means combine a number and its opposite. What do you get from these? -x plus x will be?
0.
Very good. That's right. They cancel each other out because they're opposites. Same number, opposite signs. They cancel each other out. We get 0. Okay, that's of addition. Now let's see the one of multiplication. Same thing. Inverse property of multiplication. It's a little different from the additional part. So basically what you do here, you take, let's say, fraction, or a number, could be another type of, another real number. So you take a fraction or a number, and then you get the, what we call the reciprocal. Okay, not the opposite. The opposite is when you flip the sign. The reciprocal is when you flip the number or the fraction upside down. What is the reciprocal of 2 over 3?
3 over 2.
That's right. Okay, so for the inverse property of multiplication, we actually take the reciprocal, not the opposite. The opposite is when you switch the sign. The reciprocal is when you flip the number upside down. So 2 over 3, the reciprocal of it is 3 over 2. We just flipped it. So the property says when you take that number, you times it by its reciprocal, it's always going to be the same thing over the same thing. If you times them, you'll be 2 times 3 over 3 times 2. And this is always going to be the same thing over the same thing, which is 1. So regardless of what numbers you have here, when you times a number by its reciprocal, it's always going to be 1. Without having to go through these 2 steps. We know for a fact it will be something divided by itself, and something divided by itself is always 1. So that's what we mean by the inverse property of multiplication. Take a number, its reciprocal. When you times them, you get 1. Let's look at another example here. So let's say 4. What is the reciprocal of 4? 4 is a number. What is the reciprocal of it? If you want to do something like this, that would be
1 over 4.
Exactly. So when you see 4, it may not look like a fraction, but you can always say 4 over 1. And the
Yes.
opposite of 4 over 1 is 1 over 4. So any number can be a fraction. Once you get that fraction, you can flip it. But now we're going to times that 4 by its reciprocal. We know that the result will be
1.
That's right. Any number times its reciprocal is always going to be 1. So we just say 1, because this is 4, its reciprocal is 1 over 4. Their product is 1. Or you can look at it this way. You can say these 2 cancel out. You get 1 left. That's another way of looking at it. Another example, let's say, let's continue here. So generally speaking, for any real number x, okay, what is the reciprocal again of x?
1 over x.
That's right. Everybody else in the room, are you guys okay? The rest of the class?
Yes.
Guys,
Professor, are you going to post this video on Blackboard?
I will post it.
Okay, awesome.
But please feel free to engage, ask questions. If something is not clear, let me know, okay? I want to hear from all of you. I don't want to be talking to one student only. So for any real number x, the reciprocal would be, if we put this over 1, the reciprocal would be
1 over x.
That's right, 1 over x. And of course, if you times these, if you say x, this number, or x over 1, if you times that by 1 over x, this will be again
1
times its reciprocal is 1. The number and its reciprocal multiplication is 1. Or again, you can think of it as canceling out this x. As you notice here, I used the dot for multiplication because I have x and x. I didn't want to put the multiplication sign because you will be confused with an x. So from now on, we will often refer to the multiplication with just a dot, not a decimal point unless the topic is about decimals, and that's equal to 1. So that's basically what we call the inverse property of, again, addition. Okay, and then another one for multiplication. So from here, this is another example. The next property we're going to talk about is number 5. This is the one I was going to talk about earlier. That's the identity property of real numbers. This is the symbol for real numbers. Okay, 2 vertical lines like this. Then this. It's an R, big R. That's the symbol for real numbers. For this one, we also have 2 of them. We have of addition. Okay, we have the one of addition, as well as one for also multiplication. So let's start with the addition one first. So identity property of a real number. So for addition, basically, when we add 0 to any number, does it change that number?
No.
It does not. So when you say 3 plus 0 is the same as 0 plus 3, if you commute the positions, it's still going to be 3. In other words, the 0 does not affect the addition. For any real number x, x plus 0 will be?
X.
That's right, will be x. When you add 0 to anything, basically you're not adding anything. So same as 0 plus 0 plus x is basically just x. So 0 plus x is x. That's what we call the identity property of addition. So that's what we call 0. The identity of addition. So 0 is the identity of addition for obvious reason, because 0 does not affect the addition. The next one, the next property is, still an identity property, but this time of, instead of addition, we have multiplication. If you look at this, if 0 is the identity of addition, in the same concept, what is the identity of multiplication?
0.
No. Think again. So if 0 does not change addition, so 0 is the identity of addition.
1.
But zero changed the multiplication.
But we want the number that does not change multiplication. What's that number? Someone said it.
1.
1. Right? So if we times any number by 1, let's say 7 times 1, the same as 1 times 7, that number will not change. It will be just 7. For any real number x, what is x times 1? What is x times 1? Or any number times 1 is?
X.
Itself, that's right. X times 1 is just same as 1 times x. If you switch it, it's going to be x. That's what we call so 1 is the identity of multiplication. So 1 does not affect the multiplication. So we say 1 is the identity of multiplication. So 0 does not affect addition. 1 does not affect multiplication. And that's pretty much what all these properties that we're going to need later to simplify. So let's recap again. So we saw the commutative property, only the position of the numbers change. The associative property, the position of the parentheses change. Number 3, the distributive property just means multiply. Be careful with the signs. Finally, then we saw the inverse property. So we have 2 of them. We have the inverse property. We have 1 for addition. That's when you take a number and its opposite, you get 0 when you combine them. So we have for addition, there's another one for multiplication. That's when you take a number and its reciprocal, flip it upside down. If you times the 2, it's always going to be 1. You don't even need to do the multiplication, just write 1 right away. After that, the last property we saw was the identity property. It's very simple. The identity property of addition is 0. Why? Because 0 does not change addition when added to a number or an expression. The one of multiplication, same way. 1 does not affect multiplication. If you times anything by 1, whether it's a number, any real number x, basically negative, positive, decimal, fraction, whatever, always going to be that same number. So these are the properties of real numbers. Now that we learned them, we're going to see how to apply them to actually simplify more of these, more expressions like these, what we call the algebraic expressions. Talked about this in the previous lecture. I'll talk about these more in detail and see how to simplify even more complex ones, longer ones with more terms, more x's and y's, see how to simplify them using basically these properties. Okay, any questions at this point, everybody?
No questions.
Go on. Please let me know if you have any questions about any of these properties before we move on to the next thing. Okay, so the second part is, or we can continue on with these. So let's call it number 6. So simplifying. So simplifying algebraic expressions. Again, we introduced algebraic expressions in the previous lecture. We talked about them in detail. So basically, an algebraic expression is just numbers and variables. Numbers and letters, which we also call constants, and variables. Because, for example, 2x plus 1, again, that's an algebraic expression. Why? Because it's a combination of numbers and letters. The numbers and letters, the letters we also call them variables. Why? Because their value may change depending on what we give it. You could give it 3, you could replace it by 4 or 5, whatever it is. So this is a variable, but this is a constant. Constant does not change. So number, a constant, or a fixed number doesn't change. So even if this changes, this will remain the same. So now let's see how to simplify. Let's make this one a little longer, maybe somewhere like this, and plus 10. So this is an algebraic expression with 1, 2, 3, and 4, what we call terms. Okay, term. Each term could be, if it's a variable term, there's always a coefficient. This number here in front of the x is called coefficient. This is a variable, and each variable has a power. For example, here we have an invisible 1. So that's what a term is. It has a coefficient. This is not a constant. Constant is when the number is by itself. But when the numbers are next to a variable, multiplied by a variable, that's called a coefficient. The variable itself and the power. Same thing here, we have the coefficient here, that's 3, positive 3. We have the variable, and the power is here. Then we have two constants, positive 10 positive 1 and positive 10. Two constants, fixed. They don't have variables, so they don't change in value. So when we simplify algebraic expressions, basically we look for like terms. We look for terms that look alike. That means the terms with the same variable and the same power, like this one. So these two, we can combine them because they're like terms. You can also combine these two together. So we're going to take 2x plus 1. And we're going to combine it with the like term, which is positive 3x. So we're going to move this next to its like term. As you move a term, make sure you bring the sign and the coefficient with you. So the coefficient here is positive 3. So we're going to move this next to 2x. It's a positive 3x. And then we have this constant here with its sign, which is positive. We're going to move that next to the other constant, which happens to be positive 10. So again, as you move a term, make sure you bring that sign with you. So you're going to move this back, will be positive 1. Next to that, we're going to put this one, bring this over with the sign, positive 10. That's what we call combining like terms. Okay, combining like terms. And again, means same variables. Same variable and same what? So like terms like these, they have the same variable and the same
Terms.
same power or exponent. Okay, so you have to have same variable and same power. In order to combine two things, they have to be the same. You can only combine dollars with dollars, bananas with bananas. You can't combine, I don't know, oranges with apples. You can't say two of one thing or something. They're different, so we can't combine them. That's what we call like terms. Only similar terms with similar variables and a power can be combined. So that's all we call like terms. So have to have same variables and same powers. Now that we put them together, so two of something, again, it could be dollars, could be apples, it could be anything, plus three of the same thing. Okay, what is the total of that, or the sum of that? Will be
5x.
These together would be 5x. So when you see x as a variable, it's a variable, could be anything. Could be, for example, dollar. If it helps, change that x. If it helps, change that x to a dollar sign. If it helps change that x to a dollar sign, it may make more sense. So $2 plus $3. We all know it's going to be $5. So the reason why we use x, because we don't know the value, or it's a variable. X could vary, could be anything, could be objects, could be people, could be money. But don't let it scare you or intimidate you. It just means something that changes in value. For example, dollars or money or people or fruit, whatever. 2 plus 3x. That's why these two here combine into 5x. And we combine the constants, positive 1 plus 10 would be positive 11. And that's it. We just simplified. See how this expression was so long? We had 1, 2, 3, 4 terms. Basically, we simplified it, hence the word simplifying here, into something much smaller and easier with only 2 terms. Can we add these two? Can we add 5x and 11?
I think no.
That's right, we can add them because these are not like terms. Because one has x, the other one does not have x. They're what we call unlike terms. Unlike terms don't add up. Okay, so unlike terms don't add up. So just leave it like that. Do not make the mistake of adding 5 and 11. These are different. One has x, the other one doesn't. You cannot combine them. Just like having 5 apples and 11 onions, whatever. So you can't combine them. They're different things, different items. They're unlike terms, in other words. Let's do some more examples. Okay, let's make things a lot more interesting here. 2 times x minus 3 minus 7x minus 4. So it gets a lot more interesting. The more terms you have, especially when you have parentheses, you have multiple signs, different signs. So be careful. Again, think about the rules of the signs we learned in the previous lecture. Those are very important for addition and subtraction. And then think about the rules or the properties of the real numbers that we learned today. So here's another expression, and we want to simplify. We want to make this as simple as possible. Probably maybe 2 terms like this, maybe 1, you never know. So just by looking at this, what do you think we do first?
2 times x and 2 times minus 3.
That's right. So we're going to start with the, what we call that property?
We call that property distributive property.
Exactly. So this is the property that we saw earlier here. So whenever we see parentheses, try to work inside of them if there's anything to combine. If you want to look inside here, maybe you have x's or like terms to combine. If not, then you move on to, after parentheses, we look for exponents to simplify. If not, we go to multiplication. So basically, we're still using pandas, even when simplifying algebraic expressions. So we're going to work inside the parentheses. If that doesn't work, look for an exponent that might be simplified. If not, look for multiplication. In this case, the multiplication is here. As we said, the distributive property just basically a multiplication. So we're going to multiply these two, multiply, and then we're going to bring these two down. They're not multiplying 2 and 7x, because 7x is not inside. So only what's inside would be multiplied by 2. So let's distribute this. Always clear the parentheses first. Clear parentheses first. So 2 times x, that's 2x. Then positive 2 times negative 3, that's negative 6. Again, as you multiply, think about the rules of multiplication that we learned last time. Bring these two down. We have 7x minus 4. Okay, now we cleared the parentheses. What happens next? Now it kind of looks like this without parentheses, okay? So this kind of similar to this. So
Combine.
exactly, so after clearing the parentheses, you want to combine like terms. Do we have a like term to this one?
Yes, we have minus 7x.
That's right, we have 2x.
2x minus 7x.
And that's right, so we're going to bring this over next to this one, so it'll be negative 7x. So again, when you move the term, make sure you move the sign as well with the coefficient. Then we have this negative 6 would be moved back next to negative. So negative 6, the constant with a number next to this constant. Okay, so now that we combine like terms, we can simplify and combine. So when you're combining, basically you're using the rules of addition and subtraction. So if we have 2 here, which is positive 2, so we're combining this positive 2 with a negative 7. Based on what we learned last time, the rules of addition and subtraction, what is positive 2, negative 7? Or minus 7?
Minus 5.
Exactly. So we keep the sign of the higher number, which is a negative. Then we do the difference because they're different. Okay, so when you're combining, you're actually adding or subtracting based on the signs of the coefficients. This is a coefficient. This is also a coefficient. So if you combine them, you get negative 5. So negative 5. Don't forget the variable, which is x. These are like terms because the same variable same power. If the powers were different, if this one had power 5, for example, this one had power 3, we won't be able to combine them. It will stay the same. And what's negative 6 minus 4? Negative 6 minus 4. Again, we're adding
Negative 2. Oh, positive 2. Positive 2.
not negative 2, not positive 2. Everybody else, Jessica, Laudine, what is negative 6 minus 4?
Positive 10. Maybe.
Not positive 10. Again, think about the rules we learned last time. Negative 6 minus 4. Think about the number line.
Negative 10.
X, negative 10.
That's right, negative 10. Again, refer to the previous lecture. The video is still up there. You watch that to master your signs. So this is very important. So this will be negative 10. Do we need to do anything else here?
No, we can.
That's right, these are different. As x doesn't have x, so that's the final answer. So as you can see, this expression was much more complex, parentheses and everything. We turned it into something a lot simpler. Again, that's the reason why we simplify. So you want your answers to be like this instead of something a little more complex like that. Let's look at another example. This time, say 5x to the third minus x to the second plus 4x. Okay, we want to simplify this to, so what do you think we combine? First, you start with this one. You have x to the power 3. Do we have a similar term or a like term to this one?
Yes. X to power 2.
Now, something similar to this, x3. Do we have x3 here? You don't.
No, we don't.
This doesn't have a like term. It has to be the same variable to the same power. So it stays 5x3. Now these two look like they're similar terms. We have x2, x2. We can combine them. What's the coefficient here? What is the coefficient of this term? Coefficient is basically just this number in front of the variable. Okay?
4.
This is a variable. This is a power. That's right. It's positive 4. What is the coefficient of this second term? What's the leading coefficient in front of the variable of this term?
1 or 5.
That's right, it's 1. So it's invisible. You see a negative in front of something, as we said earlier, think of it as a negative 1. When you combine these two, we're basically combining their coefficients. So the coefficient here is negative 1. Coefficient here is positive 4. What's negative 1 plus 4?
Positive 3.
Exactly. That's positive 3. You say positive 3 x. You guys have some background noise there. This turns into positive 3x to the second because we combine negative 1, positive 4, we get this. And that's it. These cannot be combined. Okay? These are unlike terms. So because even though they have the same variable, but the power is different. So therefore, we can't add these two. We can't combine them, it just stays like that. So unlike terms. So it's basically how we combine like terms. Must have, as I said before, same variable to the same power. If you don't have the same variable and same power, then we can add. Let's do another example here. Let's say maybe 5 minus 2 and 4 minus 3x. That's 10x. And maybe that's, yeah, just this one, maybe negative 7. Gonna have a long expression here. There's a lot to do. So the first thing you want to do is, again, follow up PEMDAS. Look inside the parentheses, see if you can simplify anything. There's nothing to simplify inside. Move on to exponents. We don't have any exponents to simplify. Then the multiplication. You see a multiplication right here between the 2 and the parentheses. Do not do the subtraction. It's the last thing you want to do. So subtraction comes last in the order of operations. It may seem convenient to do or easy, but that's not the right thing to do. I'm going to start with the distributive property by multiplying. So for now, we're not using the 5 yet, just bring it down. And when you distribute again, make sure you multiply the signs first. The number always has a sign to the left. Take that sign and multiply it by the sign of this one, which is positive. So negative times positive is negative. 2 times 4, that's 8. Then again, negative 2 times a negative 3x, that's positive 6x. Okay, we're done with the multiplication. Bring these two down here. Bring this one as well. Once you clear the parentheses, then you combine like terms. So we're gonna look for like terms here. So it looks like, let me add an x here just to make things a little interesting. We're gonna make x here and also here. Now we're gonna combine like terms. So we're gonna combine these two together. So we have 5 minus 8, which is negative 3. You can also combine positive 6x, positive 10x. Combine those together, that's 16, positive 6 plus 10. This 7, we're going to bring it down for now. So bring it down, it's a constant, doesn't have a variable. Then we continue. It looks like we have 2 constants or numbers that we can combine. So this positive 10 stays the same, positive 10x. Then we're going to combine negative 3 and negative 7. So negative 3 minus 7 is negative 10. And that's the final answer. You can't do anything else because this one has x, this one doesn't. So these are unlike terms. We can't combine them. And that's basically how you simplify your algebraic expressions using the properties that we just learned. Again, when you move things around like this, that's the commutative property. When you multiply, that's the distributive property. When you cancel things out, that's the identity or the inverse property. So all those properties that we learned, along with the signs we learned last time, combine them together. We use them to simplify what we call algebraic expressions, which is basically just numbers and letters together. So remember, the like terms must have same power and variable. Okay, for example here, these are like terms because same variable, same power. These, however, are not because this one has power 3, this is power 2. Therefore, they stay like that. You don't have to do anything else with them unless they had the same power. Again, don't forget the number in front of the variable here is called the coefficient. This is the variable itself, and that's the power of the variable. Okay, everybody, does that make sense to you? Any questions, any confusions at this point?
No questions.
Okay, Jessica, Lordine.
A question.
Are you guys on board?
Yeah.
Okay, any questions? Nordin, are you there?
Sorry, I thought you heard me. I said no question. Sorry about that.
Okay. All right, so that's pretty much it for today. I'll post this to Blackboard. You guys, I recommend you rewatch it. Now there was a few new terms here and properties. Make sure you review that before you do the homework. So let's take some attendance, and then yeah, let's take some attendance, and then we're gonna go head over to Blackboard to the discussion board. If you still have any questions, I'll post the homework, and if you have any questions or anything, we can go over that on the discussion board.